your 8-4B notes on graphing rational functions. So we're going to take what we learned in the previous lesson about finding vertical asymptotes and holes, and we're going to now apply it for graphing. So the very first step today will be what we did yesterday. We're going to find the vertical asymptotes and the points of discontinuity, or the holes. We're going to make a table of values around those points of those breaks in the continuity. So it just depends on what we have going on, how many tables we may need. And then we're going to draw in vertical asymptotes and holes where they are needed. So when we draw in the vertical asymptotes, we do these first on the graph before we graph. And then the holes are actually after you graph the function. You place them in afterwards. But the vertical asymptotes have to be in there before because they help guide our graph. So we're going to graph the following. The first one, if you look at it, it's already factored. There's no factors here. And so in the simplified form, my excluded value of -1 is still undefined. And so that means we have a vertical asymptote when x equals -1. There are no holes. And so what I'm going to do is I'm going to start off by creating a vertical asymptote at x equals -1. And so that's a vertical line. And what that does is it creates two different distinct areas of the coordinate plane. I have numbers that are less than -1, like -2, -3, -4. And on the other side, I have values that are greater than -1. And so what that does is it creates, I need two different tables of values. It's really important that when you make your table of values, that you stick to the area. So I'm going to make a table of values that represents the values less than -1, so -2, -3, -4. And then I'm going to make a table of values that are greater than -1, like 0, 1, and 2. Now, as you do this, and using a graphing calculator, you'll notice that there's a horizontal asymptote that we're actually approaching as well. So there's no, we don't have the formula to find the horizontal asymptotes. The graphs sort of just, it happens. So when I plug in -2, I get -2 over -2 plus 1, which is -2 over -1. I like to show my work on these, and it does show a few things happening. A negative divided by a negative is a +2. So -2 is +2. When I plug in -3, the top is -3, and then the bottom is 1 less than that. Still negative, so I have a negative divided by a negative is positive. I get +3/2 or +1.5. So at -3, I'm at 1.5. At -4, same thing's going to happen. Every time my numerator is one value greater than the denominator, they're both negative, so I always end up with a proper fraction, a positive proper fraction. Every single time, improper, where the bigger number is on top of the smaller number, which means it's bigger than 1, 1 1/3, or 1.3 repeating. So at -4, I'm at 1 1/3, so just above 1. And I can continue this over and over and over again, and what you're going to find out is that we're approaching something horizontally as well. So if I continue, okay, if I scroll down on the graphing calculator, let's just go to a -100. If I were to plug in a -100, going way over to the left, my fraction would become -100 over -99. It would be a negative over a negative, so it becomes a positive. And 100 is always bigger than 99, so it's going to be 1 whole time and 1/99 left over. So it ends up being a really small decimal, but still above 1. And what happens, it doesn't matter if I go to 1,000,000, if I go to 1,000 or 1,000, 10,000, I'm always going to have an improper fraction that's positive. And so what that tells me is I'm never, ever going to go drop below 1. That is your horizontal asymptote. So your horizontal asymptote, it just reviews your table of values, and you realize this graph keeps getting closer and closer and closer to 1, but it's always above 1, and it never goes under it. And so we've just established that positive 1 is my horizontal asymptote. So my horizontal asymptote is y equals 1. Once we establish that, we find that, we put it in, and then that creates, that's a horizontal asymptote for the other side of the graph as well. So I have enough information now where I can connect, and I'm going to approach both asymptotes without crossing them. So now what I need to do, I need to decide how is this other graph going to be. The only place it cannot show up is down here, because if the graph showed up down there, we wouldn't pass the vertical line test. So I know the other curve is not going to be underneath, but what we could have is we could have the curve come down here, or they could be back to back. So they're going to approach both of the asymptotes, the vertical and the horizontal asymptote. We just don't know which direction. So that's where the other ordered pair, or the table of values, comes into play. So when I plug in 0, I really don't need as many ordered pairs for this table. When I plug in 0, I get 0 over 1, which is 0. And that really, right there, that 1 point, tells me everything I need to know. It tells me I'm going to be in that bottom quadrant rather than above. Okay, so I have to approach here. I'll never be greater than 1. And I'm going to approach from this side because I can't equal negative 1. If it equals negative 1, this thing doesn't exist. Let's talk about this part of the graph that I just sort of said. I'm approaching positive 1, but from underneath, which means I'll never quite reach 1. I'm just below it. So if I plug in 1, just for fun this one time, 1 over 2 is a proper fraction. It's 0.5. When I plug in 2, I get 2/3, which is 0.6 repeating. If I plug in 100, if I go all the way 100 units to the right, I'll still have a proper fraction of 100 over 101, which is like 0.9 something. So the more I go to the right, the closer I'm going to get to 1. It'll be like 0.9999999, but it never quite equals 1. Because when you put a number over a number plus 1, you'll always have a proper fraction, and proper fractions are always less than 1. That's kind of the definition. So you can have a number equal to 1, you can have a number less than 1, or greater than 1 when you deal with fractions. So this is our function. The next type of graph, we have to factor first. So I'm going to factor the top, and it becomes x plus 2, x minus 2, and the bottom is still x minus 2. So my undefined term is 2, but when I simplify it, it looks like it's defined. So what this function looks like is a line. H of x is equal to x plus 2. It's going to look like a line. We can use slope and y-intercept to graph the line. We can use a table of values. But in the end, I'm going to have a hole at x equals negative 2 something. I really don't care what the ordered pair is. Just put a little question mark. But it's going to be a hole at that ordered pair. There is no vertical asymptotes. There is no horizontal. So it's going to write none. So I'm going to go ahead and graph x plus 2. It's a line. I start at positive 2 on the y-axis. I count up 1 over 1 for my slope. And down 1 to the left. There's my line, but it's not a line. If it was a line, it wouldn't have an x minus 2 in the denominator of its original form. So it looks like a line. It has all the characteristics of a line, except for when x is equal to negative 2. So I'm going to find when x is equal. So I'm going to come over here where x equals negative 2. I'm going to come up to the graph, and I'm going to actually take a hole out of that point. So when x equals negative 2, and actually it probably should have hit 0 if my graph was correct when I went down 1 over 1. It should have been right at the x-axis. So you just literally pull that point out, and you say that's the only point we're not going to be defined for. So you remove that. So by doing that, just make it obvious that you're putting a hole at negative 2. And that's graphing. So what I need you guys to do, freebie on the lesson summary, and I need you to graph this rational function below. Good luck.